When we deal with gases in the lab, it's important to have standards by which we measure things with, because we know when we increase the pressure on a volume of gas, that gas will get smaller. Decrease the pressure, the gas will get larger by Boyle's law. Similarly, there's a second law called Charles' law, where temperature will cause a gas to expand or contract. The warmer the temperature, the greater the expansion. The colder the temperature, the greater the contraction. To get some standards so that we know what we're talking about, we have two possible terms. STP, which stands for standard temperature and pressure, and then a second variation on that, which is SATP, or standard ambient temperature and pressure. STP is defined as 101.3 or 101.325, technically, kilopascals. And so if you watch the weather forecast or read it online, they often give you atmospheric pressure in terms of kilopascals. You'll always see that it hovers right around 100 kilopascals. Standard temperature is 0 degrees Celsius, which in terms of the Kelvin scale, which we'll talk about, is 273 kelvins. Standard ambient temperature and pressure is tended to be almost the same thing. Standard ambient pressure has been simplified to be 100 kilopascals. And so it's just an easier number to remember. Standard ambient temperature is what you would expect to get in a lab, as well as being a nice round number. And so standard ambient temperature is 25 degrees Celsius, which is actually just 273 plus 25 degrees Kelvin, so 298 Kelvin is standard ambient temperature.